Next, induction. Induction is charging an object without ever touching it. We don't have to charge an object. We don't have to touch an object to charge it, because remember, the electrostatic force is a long-range force. It's a long-distance force. You just have to bring another charged object nearby, right? So that's the method, bringing a charged object near to another object. And the end result of induction is that the two objects involved end up oppositely charged. This is different than conduction. With conduction, we ended up with the same charge. Here we end up with the opposite charge. Here's how it works. On the left, we have a diagram of two neutral objects. Let's just say they're neutral. Once again, neutral doesn't mean no charge. It means equal numbers of protons and electrons. In the second picture, what we're going to do is simply bring a negative charge close to, but not touching. We don't want it to touch because I don't want electrons to jump from this one into these objects. But what this is going to do is it's going to force electrons to move away from the negative charge, because like charges repel. Now, get this. Notice there was an equal distribution here already. What we've effectively done is just polarize this object, which means we've created a negative side and we've created a positive side. And the way that we've done that is simply by moving a negative charge close by and cause electrons to move away. Note, if this charge is positive, think about this, what directions would the electron go? Hopefully you decided that the electrons would move to the left toward that positive, because those are opposite charges and they would attract. It just so happens in this case that I'm using a negative to illustrate this, and so the electrons are going to move away. Once again, I want you to note here that there is no movement of protons. We need to understand that the reds here are the protons. They stay put. Why do they stay put? Because remember, they're in the nucleus, glued in with that strong nuclear force. The only thing that's going to travel is the electrons, and they either go away from the negative, because those are like charges, or toward the positive, because those are opposite charges. So we've now polarized, either you could polarize one object or two separate objects by the presence of another, don't have to touch it. Now that it's polarized, what we can do is maintain this polarization by keeping this one here, but we can separate these two so that charge can no longer flow between the two. Once they're separated, we can then remove the negative charge, and we have effectively charged these two objects. They were neutral. Now we've charged them, and I never had to touch them with a charged object. This is called induction. We bring a charged object nearby, causes the objects to polarize, and that polarization can be separated to make a negative and positive charge. I want to reiterate once again, this object over here on the left did not gain any protons. No protons traveled anywhere. All that happened is electrons left it. So it became less negative, therefore positive. B became more negative, it gained more electrons, so it has a negative charge. Now, there's a few illustrations of this, a few examples of this. First of all, it's very similar to something you might remember from chemistry, which is called van der Waals forces. And there's two good examples of van der Waals forces. Here's one.
So let's say you want to stick a balloon to a wall. Usually, of course, the balloon will just not hold and fall down. Now you have two choices. Either you tape it to the wall, or you use physics. When you use physics, actually what will happen is, if you charge your balloon, it will stick to the wall. To charge balloon, either use your cat, or if you don't have a cat, you have to use your own hair. Now the balloon should be charged, and it will hold on the wall by itself like magic.
Just like magic. So what he did actually was the third type of charge transfer that we'll talk about in a minute. It's charging by friction. And what he did is to transfer electrons from his hair to the balloon. Now, the interesting thing about a balloon is it's obviously made of rubber, which is an insulator. So once those electrons get deposited on the surface of that balloon, they're not going to move. That charge isn't going to transfer. They're going to stay on one surface. You might have noticed that he put that surface on the wall, and what it does is the presence of this negative drives all of the negative charges in the wall, drives all of the electrons away. They're going to go away as far as they can get. get. And what it does is it leaves the surface of the wall, those protons stayed there, it leaves the surface of the wall basically positively charged. And so now we can get this attraction because the negative surface of the balloon is attracted to the positive surface of the wall. That's kind of like van der Waals forces, and geckos do the same thing. I'm sure you've seen these guys in your house. Check this out.
Oh. How do geckos stick to walls?
Using a two-sided tape.
Nah. The toes of geckos have hair-like structures called setae. Each of these setae branches into tiny bristles called spatulae. Spatulae help geckos to stick to many surfaces using the principle opposite charges attract. Now, molecules of a body or an object are usually electrically neutral, but these molecules have a side that is more positive and a side that is more negative. When geckos walk on walls, they place their spatulae at such an angle that their positively or negatively charged sides get attracted to the opposite charges present on the wall's surface. These forces of attraction are called van der Waals forces.
Wow, that's an impressive name.
Now, a gecko has billions of spatulae on its feet. Hence, they create enough van der Waals forces so that geckos can stick to walls.
So that's why geckos can very easily walk on walls and on ceilings. You might have noticed here that the gecko is intentionally orienting these cells. Actually, the cells orient themselves because the positives are deflected away from the positive and the negatives are attracted to that positive surface. And it would be vice versa if the surface of the wall was negative. But that's basically how geckos can climb so easily on walls and on ceilings. It's basically the concept of induction.